Okay, so we'll review what we did yesterday. Then we're moving on to something not that new, actually, but we're going on to what we call vertex form, and we'll have a lot of practice on that today. So quick review. I have a box over here with a bunch of keywords in them, and I have some examples over here on the right. And I basically want you guys to start in your heads for now, and then we'll talk about it, but start matching each of these examples to the correct type of transformation. So as a reminder, we have vertical stretch, vertical compression. We just talked about reflection over the x-axis. We talked about vertical translation, and we talked about horizontal translation. And then one of these is the parent function. So start looking at it, start matching it in your head, and then in a little bit we will actually match it. What is that, a 5? I haven't even labeled them yet. How do you know which one's which? Here's A, here's B, C, D, E, and F. So not yet, but in a little bit, we will go ahead and put all the answers down. But for now, I just want everyone to do it in their heads. Juan, in your heads, please. Just 10 more seconds. All right, now go ahead, use the annotation tool and just place the answer right next to each of these vocabulary words. So I already saw that somebody had put something for parent function. And let's see if we agree. All right, so parent function is E, that's good. Vertical stretch is F, that's also correct so far. Vertical compression, that's B, good. Reflection is C, good. Which one's my vertical trend? So here's where we're gonna be very careful. One of those other ones is vertical and the other one is horizontal. So take a look at A and D and try and see which one's which. Okay, vertical translation D, good. And horizontal translation is A. Good, we got them all, nice. So let me quickly just go over these. So in case anyone who was absent yesterday just needs a quick refresher. E is the parent function. So E is where we compare everything to the parent function, because the parent function is like the original, the OG. So looking at answer choice A was moved over to the left, 3 units to the left. That's why answer choice A is a horizontal translation, because it's going 3 units to the left. And if you look at the equation, what happens? Why is there a plus sign there? It's going to the left, so why is there a plus sign? Who can tell me?
This goes back, right?
It goes to the left 3 units, but I see a positive 3 on the inside of those parentheses. So what do you always have to do in your head?
You're gonna have to.
What?
I remember a little bit from this topic that we like, if you do x negative x or whatever variable, it goes to the right. And if you do x plus something, it goes to the left.
Yeah, it's the opposite, exactly. So in your head, you kind of want to think, okay, I got to kind of flip the sign first, and now it's going to go in that direction. So even though it's a positive sign, it goes to the left. But that only happens on the inside of the parentheses. Okay, then answer choice D goes down 7 units. 7 units down. So answer choice D is my vertical translation. Vertical is up and down. Since this goes down 7 units, that's why it's vertical. And we have a -7 in the equation. So I'm going to kind of highlight all of those little things right here. Okay, answer choice B is a vertical compression. And we say that it gets wider. So it's wider. And for that reason, it's a vertical compression. And that happens because of this fraction right there. The fraction, the 1/4, makes it wider. Now, answer choice F, on the other hand, is a vertical stretch because in answer choice F, it got skinnier. It got skinnier, and that's because of the 4. The 4 makes it skinnier. And then finally, answer choice C, that's our reflection. This is the reflection. It flips, and that's because of the negative sign in the front. So those are my 5 types of transformations. Do I have any questions on those 5 types of transformations? Awesome. Okay, and then last thing, this is our last part of the review from yesterday. I'm going to just go ahead and I'm going to write down all of the mathematical transformations because right now we were looking visually, but we're going to write down all of the different like rules of how these transformations happen. So we wrote them down yesterday. If you were here, if you already wrote them, you do not have to write them again. But especially if you were absent or if you didn't write them down or I don't know, you didn't have time, now is a good time to copy them all down. So parent function, f of x equals x squared. Very simple. The leading coefficient is 1. So remember, a is the leading coefficient, and it equals 1. Opens upward. And the vertex is at the origin. It's the most basic parent function, and it's the one that we compare everything else to. Then we've got vertical stretch. Vertical stretch is when you have a leading coefficient in the front. And who can remind me, when you have a vertical stretch, what is the value of A going to be? What type of number?
Greater than 1.
Good. A is greater than 1. So vertical stretch, it gets skinnier, it stretches out, and that's because A is greater than 1. On the other hand, you got a vertical compression. Again, that's when you have a leading coefficient, but this time, what's the leading coefficient? What
Less
type
than
of
1.
It's less than 1, and what type of number is it specifically?
A fraction.
A fraction. So you got to be careful because it's less than 1, that's true, but it's also still going to be a positive number. So it's not a negative number, it's a fraction. So what we say is that A is between 0 and 1. A is between 0 and 1, so it's a fraction. Now a reflection, that's when we have a negative number. Let me just put a negative there. Make that a little bit neater. All right, so that's when A is less than 0. A is negative. Questions on those three so far: vertical stretch, vertical compression, or reflection? Okay, and now we have vertical translation. Vertical translation goes which directions?
Left and right.
Careful, what's vertical?
Up and down.
Up and down.
Up and down. So that's when we add not a coefficient, but a constant. So the constant at the end of the equation. And it goes two different ways. So if k is positive, if k is greater than 0, it's going to go up k units. And if k is less than 0, it's going to go down k units. So vertical translation goes up and down. And then finally, horizontal translation. The big difference, the very obvious difference with horizontal is that there's parentheses. So those parentheses are a big giveaway. If you see parentheses, you know it's going to go horizontal. And for horizontal translation, we flip the sign of H. You got to think backwards. And then if H is greater than 0, it goes to the right. And if H is less than 0, it goes to the left. So kind of a bit of a review of this was everything we talked about yesterday. So now is a really good time to ask any questions you still have about this. All right, I'm going to give everybody about 30 more seconds to continue writing. All right. Anyone still writing? Anyone still copying?
Me.
Okay, I'll give you a couple more seconds. Juan as well? Okay. Take your time.
I'm done.
Awesome. And Juan, just let me know when you're done and then we can move on. All right, cool. So we have all of these different transformations. We've got like 5 different ones, but what we can do, oh, my bad, never mind. We have a couple of practice problems real quick. These won't take too long. I forgot they were here. Very quickly. So because we have all these different transformations, we don't always need a graph because mathematically you can also figure out what's going on. So just looking at the numbers, who can tell me how is the graph of g of x equals x squared plus 12 related to the graph of the parent function? So what changes?
They add 12.
They add 12. So this right here is my k. K equals 12. So what does that do to the graph?
It goes up.
Up 12 units. So g of x is up 12 units from f of x. Now, does anything change? Anything else change? It moves up. Does it become wider, skinnier, anything
It
else?
becomes skinnier
Why?
because it's above 1. They're adding more than 1.
Okay, and let's go back really quickly. When something gets skinnier, that's a vertical stretch. What number changes for a vertical stretch? Which number changes?
The coefficient?
The leading coefficient, right?
Oh.
Did the leading coefficient change at all?
No.
No, it's still a 1. Remember that there's a difference between the number that's all the way in the front, that's the leading coefficient, versus the 12, which is a constant. So the constant changes, but the only thing that happens is if you think about, this is my parabola, it was down here, now it's up here. Does it get wider? Skinnier? Does it
No.
flip? Nothing else happens because the only thing that I changed was the constant, the value of k. I did not change the value of a or h at all, just k. Is that okay? We understand that?
Yes.
Awesome. Okay, here's a couple more. Same kind of question. So what transformation happens in these examples? Starting with the one on top. What's going on here?
It's going to the left.
Good. So here's my 12. This is a positive 12, but I got to flip it in my head. H is negative 12. So what happens is it goes 12 units to the left. On the other hand, what's going on here?
It's going to the right.
Going to the right. Flip the sign in your head. H is positive 10. So that's going to be 10 units to the right. So when it's inside of the parentheses, you have to be super, super careful and remember that you got to flip that sign. Questions on these two? Awesome. I have a request real quick to just go back to this slide so that someone can take a screenshot. And this goes for any, if you guys want to take a quick picture of this slide or a screenshot of this slide, go ahead and do so. All right, cool. All right, now we're going to go ahead and move on. So we have those 5 types of transformations, and so far we've been looking at them all separately. But now we're going to see what happens when we put them all together. So this is called vertex form. Vertex form is a way to write a quadratic function. Think about how with linear functions we had slope-intercept form, we had standard form, we had point-slope form. With exponential functions, we had standard form, we had exponential growth form, we had exponential decay form. Quadratic functions, this is just one way, and we're going to learn a few other ways, but this is just one way to write a quadratic function. But guys, y'all are freaking out for no reason because you already know what each of these things does. What does A do again? If I change the value of A, what happens?
It stretches.
It could stretch. What else can happen?
Compression, vertical compression.
Compression, and if I turn it negative?
No. Compression.
That would be if it's a fraction, but if I turn it negative, Reflection, there we go. So we already know, guys, we already know what this does. So A is just gonna controls the size and direction. We already know this. We
Miss, what do
just
you
wrote
mean
it
by
down.
that?
We just wrote what we've been talking about so far. If A is greater than 1, what happens to the graph? If A is
Become
greater,
skinnier?
so it's a stretch. If A is between 0 and 1, if it's a fraction,
Oh, I get what you're saying. And when you're talking about direction, you mean like up or down?
I mean like facing upward and facing downward, yeah. So if it's negative, if A is negative, we know that there's a reflection. So the leading coefficient, the A, whatever number is out in the front, it's going to tell you a lot about the graph, right? It's going to tell you if it's going to be a skinny graph, it's going to tell you if it's going to be a wider graph, and it's going to tell you if it's facing upward or if it's facing downward. So just by looking at that number, and in just the next slide we'll see our first example, but just by looking at the number, you can tell me a lot of different things about the graph. You can tell me where it faces, does it face up or down? And you can tell me if it's going to be a skinny graph, if it's going to be a wide graph, or if it's going to be a neutral graph. So A, we already know what it is. We've been talking about it this all along. What does H control? What does that number do?
It goes to the right.
To the right and or to the
Left.
left. So we have, this is controls, hold on. The horizontal translation. This is nothing new. We just went over this. We got to remember to flip. And then once you flip it, if H is greater than 0, it goes to the right. And if H is less than 0, it goes to the left. We're not changing a single, this is all, we already know what this is. Nothing new. And then K controls the what? Oh, thanks. I did put the letter R. My bad. And K controls the? If H is horizontal, K is vertical. And for K, it's super easy. You don't have to flip anything. If K is a positive number, it goes up. If K is a negative number, it goes down. So we've got just all of the different transformations that we've already seen and already talked about. We're going to be putting them all together, all in one. Now, there's one last thing about vertex form. It's called vertex form for a reason. Because what happens is that you can always figure out where the vertex is by looking at H and K. The vertex is going to be at the coordinate point that is just H comma K. Because if you think about it, the parent function starts at 0 comma 0. H moves it to the left and to the right, and K moves it up and down. So if I'm moving it to the left, to the right, up or down, I'm going to end up in a new place. That new place is my new vertex. So just by looking at those two numbers, you can already tell where the vertex is going to be. And I know that this feels like a lot of information all at once, but we're going to do like 5 examples from now till the end of class, and it'll make a lot more sense when we actually see it. But do I have any questions up to this point on this page? Okay. Anyone writing? Still writing?
Me.
All right, take a moment. All right. Okay. Let's take a look at our first example. So what we're going to do, I have not put it on the graph yet. I haven't put it on the coordinate plane yet, because what we're going to do is first we're just going to look at this function equation. And now I have numbers, right? I know the value of a, I know the value of h, and I know the value of k. So I want to start by writing those three things down. What is my a? Which of those numbers is a? Yeah, Jeffrey, you got it.
The
Put it in the
2.
chat. Yeah, the 2. A is 2. What's h?
-1.
-1.
Okay, and what do we have to do with that sign though?
Flip it.
Right.
Flip it. So it's +1.
I mean, it's a
Oh, my
positive.
Yeah, that's always the hardest one. So we'll get used to it. Just always remember to flip the sign when you're talking about h. And then k?
7.
Do we have to flip the sign for k?
No.
Nope. So for k, it's exactly as you see it. It's -7. So h is the only one that you just have to remember to flip. And I know that that sounds kind of weird and like might be confusing right now, but we'll explain why probably tomorrow. So for now, just try and train yourself to remember that. Okay, so now those are all my values. So let's talk about what happens to the graph. What type of translations are going to happen? If h equals 1, what does that do?
Goes to the right.
To the right 1 unit right. And if k is -7, what's happening there?
Goes
Go
down.
left.
Down. Yeah. 7 units down. So it goes 1 unit to the right and 7 units down. Now, when I say that, that's starting from the origin. So from the origin, this is telling me, okay, go 1 unit to the right and then go 7 units down. 1, 2, 3, 4, 5, 6, 7. This is a weird graph. It's going by like threes, so it's kind of off. But where is my new vertex going to be? Remember that the vertex is always going to be at h comma k. So where would my vertex be in this case?
1,
-7.
Yeah, exactly. 1 comma -7. That's where my new vertex is. So see how I don't have a graph, I don't have anything visual yet, but I can already determine all of those things just from the equation, just from what I see in front of me, just from all those numbers. So I have my new vertex. Now, based on the value of a, what do I have? A equals 2. So what does that do?
It stretches.
Good. Vertical stretch. And since A is +2, is my graph going to be opening upwards or is it going to be opening downwards?
Upwards.
Upwards. So take a look. We already know. Basically, we can put a sketch of this graph right now because I already know the vertex. I know it's going to be skinny, and I know it's going to open upwards. So let me go to the vertex. It's 1 comma negative 7. And like I said, I don't like this graph because it's going by threes, which means halfway is 1.5. But I'm going to just do my best. So 1 comma negative 7 is going to be somewhere over here. And it's opening upwards, and it's going to be skinny. So when I sketch it, I know it's going to be maybe something like this. Now, I don't know for sure yet, but I have an idea of what it's going to look like. And that's really, really important because even if I don't know exactly where it is, let's say you're taking a test and you have multiple choice answers, you can eliminate a lot of answer choices just on what you know from the equation, right? Because if you had an answer choice that was opening downwards, or you had an answer choice where the vertex is in a different place, you can eliminate those right away. So it's really cool how you can already understand so much about a graph just from looking at the equation. Do I have any questions so far? We're not done yet, but any questions at this point? All right, I had one question in the chat. I just want to say it out loud. For H, do we always move to the right? What do you guys think?
No.
No. When do you move to the right?
When it's when it's negative.
Right. So the original thing is negative. You got to flip the sign, right? So we flip the sign. So when it's a minus sign, it goes to the right. And when it's a plus sign, it's going to go to the left. So with H, it's a little tricky, but we'll do a few examples so you'll see the difference between when it goes to the right versus when it goes to the left. Okay, so now I have a sketch of my graph, but I want to have something a little bit more concrete, a little bit more accurate. So the final thing that we're going to do is we're going to make a table. And well, the vertex, you can think of the vertex like the center, right? Because what happens on both sides of the vertex? Think about visually. What happens on either side of the vertex?
It goes to infinity.
It goes to infinity. It goes up on both sides. And remember, there's an axis of symmetry. So whatever happens on the left side of the vertex, what's going to happen on the right?
Oh, I think I understand what you're trying to say. Like for on the left, x is going to be negative, and then on the right, x is going to be positive, and then on the left, y is going to be positive, and then on the right, y is going to be positive.
So whatever happens on the left side is going, even if one side is negative and the other side is positive, they're still going to match. It's going to be whatever happens on the left is reflected over to the right. It's the same on the right side. So the vertex is kind of like my center. So what I'm going to do is I'm going to put down my vertex, 1 comma negative 7. And all I'm going to do is I'm just going to figure out, okay, what happens to the left, so at 0, and what happens to the right at 2. All I'm doing is 1 point on the left and 1 point on the right. And the reason I'm doing that is just so that I can make it a little bit more accurate, But this is very, very simple because I have an equation, don't I? I have this nice, beautiful equation right here. And I want to know what is happening at the 0, what is happening at the 2. So what can I do with my 0 and what can I do with my 2? Since I have that nice, beautiful function equation, what can I do with my 0?
Find out where the y meets 0.
How would I do that?
Go to the x-axis.
But remember, my graph that I put up is not accurate right now. It's an idea of what it looks like. But I have a beautiful, beautiful equation. Look how beautiful that equation is. It's purple, it's lovely. What can I do with that equation?
Add one of the numbers.
Yeah,
Plug
that's what you
in
can do.
the numbers.
Plug it in, exactly. We're gonna plug it in. We're gonna plug in 0 and see what I get. I'm finding g of 0. I'm going to plug in my 0 wherever I see x. Because then whatever I get as my answer is my output value. 0 is my input. Whatever I get is going to be my output. So let's go ahead and see what happens. Order of operations, what should I do first? I have all these things. I see multiplication, I see an exponent, I see subtraction, I see parentheses. What goes first?
Parentheses.
Parentheses. 0 minus 1.
-1.
Good. -1. And then what goes next?
Exponents.
Exponents. So what's -1 to the power of 2?
+1.
+1. So I have 2 times 1 minus 7. 2 times 1
2 times 1, 2.
is 2. And what's 2 minus 7?
-5.
-5. So my output is -5. 0, comma, -5. So what did I just do? I wanted to know what happens at 0. So in order to figure it out, I had to plug in my 0 as my input and then see what I get as my output. So now I know a little bit more accurately what this graph is going to look like. But I'm not quite done because now I also have to do the same thing with my 2. But does anyone have any questions on how I plugged in my 0 and how I got my output? Okay, so now I'm going to do the same exact thing, but this time I'm plugging in 2. So 2 is my input. And let's see what I get. Same thing, we're going to do parentheses first. So 2 minus 1, what do I get?
1.
1. 1 to the power of 2.
1.
1. 2 times 1 is 2. And 2 minus 7.
-5.
Oh, I get the same exact answer. Interesting. Why does that happen? How come I got the same answer?
Oh, because it is. Wait, I don't know.
It's okay.
Is it reflected?
Because what is happening on the left side of the vertex versus the right side of the vertex? They match. It's going to be the same. Whatever you get on the left, you're going to get on the right. So let's take a look. So now I'm going to make this graph a little bit more accurate. I'm going to go to 0, comma, -5. And I'm going to go to 2, comma, -5. So here's this right here. And that just helps me to determine a little bit better the shape of my parabola. So it's a little bit more accurate.
Oh, okay. Now I understand.
Good. How do we feel? Do I have any questions? at this point? And that's it. That's my graph. I am done. I have successfully placed my graph on the coordinate plane. Now, how did I do it? First thing we did was a sketch of the graph just to have an idea of where it's going to be and what it's going to look like. Then I had to plug in an input value to find the output. And I wanted to do that on one number to the left of the vertex and one number to the right of the vertex so that I can get a more accurate graph. Now we're going to do this 5 times till it makes more sense. So at this point, can everybody let me know? And I'm going to compare it at the end using your emojis, or send me in the chat. Let me know, how do we feel about this so far? It's okay if you still feel confused or a little like unsure about it. Guillermo's giving me 2 thumbs ups. That's good. Okay, I'm seeing an 8 out of 10. Jeffrey feels good. Okay. How about everyone else? I got a lot of other students here. How do we all feel? And like I said, it's okay if you're not feeling so good, that's okay. That's okay. But I'd rather know so that I know going forward how to proceed from here. Lauren's feeling pretty good. Karina's maybe a little confused still, but that's okay. I know you'll get it eventually. Are else pretty good? Okay. All right, not too bad. With practice, we'll get it. I promise you that. Okay, let's do another one. Okay, so first thing, we're just going to break down the equation, same as before. I want you guys to tell me, what is the value of A, what is the value of H, and what is the value of K? So, what is A?
-3.
-3, good. What's H?
+1. I
You
mean,
sure?
negative.
Ah, -1, good. And K?
-2.
-2. Awesome. Okay, so translations. What direction? How many units?
It goes to the left -1 times, and then
So
it goes down 2 times. I messed up, but
that's okay. I understood you. 1 unit to the left and 2 units down. Perfect. Where is my vertex?
-1, comma, -2.
You got it. -1, comma, -2. H, comma, K. So I'll write that down one more time. So the vertex is always going to be at H, comma, K. So -1, comma, -2. And then finally, since A equals -3, what's this graph going to look like? What are some characteristics of the graph?
It's gonna face downwards.
Faces downwards, good. And what else?
it is compressing. No, wait, no. It is reflected.
We already said that. So it's opening downward because it was reflected, right? The negative sign tells me that it's going to be facing downward. But then what about the 3? What does that do? What type of?
It goes skinnier.
Skinnier. What do we call that?
Stretch, vertical stretch.
Stretch, good. Vertical stretch. So it's going to be skinny. All right. And that's everything. So I'm going to make my sketch of the graph, but it's not going to be perfect. It's just an idea of what it's going to look like. I know the vertex is at -1, comma, -2. I know it's facing downward and it's going to be pretty skinny. So I think it might look something like this. But again, that's just a sketch. This is not an official graph. In order to figure out what it actually looks like, I'm going to have to plug in some values. So same as before, I'm just going to make a little table. And which point do I put at the center of my table?
May you repeat the question, please?
Sure. When I'm putting numbers down on my table, I want to start with what I already know. So what do I already know about this graph? Which point?
X is -1 and Y is -2.
Good. So I always put down the vertex, and then I'm going to go 1 point before the vertex and 1 point after the vertex. So what number comes before -1?
0.
So 0 on the one side, and then on the other side,
1.
not 1,
-1.
-2.
-2. -2 is on the other side. So it's one number right before the -1 and then one number right after the -1. And those are the input values that we're going to plug in. And then we're going to figure out what's going on the Y value. So we're plugging in. The most important thing when you're plugging things in is just to make sure that you're following the order of operations. So we're doing things very carefully. I have my nice, beautiful equation. I'm going to go ahead and copy it down. And I'm plugging in my -2. Order of operations, what do I do first?
Parentheses.
Parentheses go first. So -2 plus 1, what do I get?
-1.
-1. -1 squared, that's what I do next. My exponent goes next. What do I get?
+1.
+1. -3 times 1.
3.
-3 times 1.
-3 times 1, -3.
And -3 minus 2.
-5.
-5. Oh, that's a weird coincidence. I also got -5 on this example. -5. Questions on when I plugged it in and all those steps that I just took? All right. So now I'm going to do the same thing, but now I'm going to plug in 0. And I'm going to do it, but what do you guys think is going to happen?
It's going to be -5.
It's going to be it probably is going to be the same, but let's just, I'm going to show you why that's true. 0 plus 1,
0 plus 1, 1.
1. 1 to the power of 2,
1.
1. -3 times 1,
-3.
and -3 minus 2,
-5.
-5. So we do get the same value on both sides. Because again, what happens on the left side of the vertex is copied over on the right side of the vertex. So you end up with the same thing on both sides. So now I'm going to make my graph a little bit more accurate. I think I didn't make it as skinny as I should have. So -2 comma -5 is over here. 0 comma -5 is over here. And yeah, it's pretty skinny. Nice and stretched. And there it is. So how do we feel now? A little bit better? Any questions? Kind of getting the hang of it?
Mm-hmm. I'll add an extra 0.5 to my 8/5.
Okay, good.
I'm sorry.
Little by little, you'll get up to a 10 and eventually. Any questions?
Oh, RL, your mic is not like.
Yeah, I couldn't really hear you, RL. It's a little like muffled. I don't know. But if you have a question, you can type it in the chat for now. That works too. Alrighty. Okay, let's do another. Let's keep it going. Keep the party going. Same few steps. Start with labeling everything. What's my A? What's my H? What's my K? Okay, here is RL's question. Let me go back to it. Why does the -3 make the graph stretch? Good question. Remember, the negative sign makes it flip. The negative sign makes it flip, but the 3 on its own makes it stretch. So you kind of want to think of the negative sign and the 3 as two separate things. The negative sign makes it stretch out, or sorry, the negative sign makes it flip, and the 3 makes it stretch out. So for example, if you had something like this, if A was -1/4, in that case, it would flip and then it would be a compression. So the negative sign is kind of its own thing. And then the number itself, if it's a fraction, it's a compression. And if it's a whole number greater than 1, it's a stretch. Okay? Good question. Okay. So back to this one. What is the value of A in this one? I'm seeing it in the chat. Yeah, Jeffrey, RL, you guys are both right. It's a -1. All I see is a minus sign, right? But we know that whenever there's a minus sign just hanging out all on its own, it's technically a -1. Okay, so A is -1. What about H? H is 2, good. And K? Good, K is 4. All right, so the only one that was a little bit different this time is that value of A, but everything else still follows the same rules. So what are my translations? Where am I going?
Two to the right, up 4.
Good. 2 units to the right, 4 units up. Where's my vertex? Good, Jeffrey. 2, 4. 2, 4. It's the H, K. 2, 4. And if A is -1, what's happening to my graph?
Reflect.
There's a reflection, yeah. So it's, where is it opening? Upwards or downwards? Good, downwards. Is there a stretch or is there a compression?
Stretch.
There's a stretch and compression.
Stretch and compression.
Oh, no, not compression. I'm sorry, only stretch.
Only stretch. What is making it stretch?
The negative.
The coefficient in front.
And what number makes things stretch? What types of numbers make something stretch?
Negative.
Oh, a number that's greater than 1. This is less than 1.
It's not, remember, just the number itself. The negative is a separate thing from the number itself. What number do I have for A?
1.
1.
Negative.
Negative.
It's a negative, but it's still a 1. What does a 1 do?
Nothing.
Nothing. So the only thing that's happening is that it's opening downwards, but the width, it's not stretching, it's not compressing, it's going to be neutral. Because the actual number 1, okay, that's the difference. The negative sign is what makes it flip, but the actual number itself controls the width. So since all I have is a 1 isn't going to do anything. It's just going to leave it nice and neutral. Does that make sense? And that kind of goes back to what RL was asking on this problem. Since A was a negative, it was going to open downward, but because it was a -3, the actual number 3 made it stretch. Here, the number is a 1, which does nothing. That's the difference. All right, 2, 4 opens downward, no stretching, no compressing. I think it can go a little bit wider than that. Maybe something like that. But that's just a sketch. I don't know for sure quite yet, but let's find out. Let me move this over a little bit. Okay. I make my table. What do I put on my table again? What am I putting on my table?
2, 4.
2, 4. And then one number before that and one number after that. So what number goes before the 2?
Before the 2, 1.
1. And then after the 2?
After the 2, 3.
It's 3. Those are my inputs. That's what I'm going to plug in and then see what I get. So now that we're kind of getting the hang of it, I'm going to give you guys the opportunity to do this part on your own first. So I have my equation.
Do we type it in the chat?
Yeah, you can give me your answers in the chat. So you're going to plug in 1. Start by plugging in a 1. Remember to follow the order of operations. I'll give you about a minute and let's see what we get. All right, take about 10 more seconds. Okay, let's take a look. Starting with my parentheses first. What's 1 minus 2?
1 minus 2 is -2.
Negative, careful, negative what?
-1, I mean, I'm sorry.
-1, good. -1 squared is?
+1.
+1. -1 times +1
-1.
is -1, and -1 plus 4
3.
is 3. So I get 3. What would I get if I plugged in positive 3?
Huh? Oh, 3.
Yeah, I get the same thing. So I don't even need to do it. I already know I've shown it a few times already. So at this point, you know that it's going to be the same exact value. Any questions on that? Okay, cool. And let's go ahead and put that down. One comma 3 and 3 comma 3. Hey, I was pretty good. This was not bad. I think I made mine just a little bit skinnier than I was supposed to, but my sketch wasn't too bad. There it is. My final answer. So we've done this 3 times now. Hopefully it's getting a little easier and easier. I'm noticing that more people are starting to put their answers in the chat, which is good, but I would love to hear more people starting to say their answers out loud as well. Now that you're getting a little bit better at it, a little bit more confident with it, I do want to hear more from everybody. Any questions on this one? No? No questions? All right. So on this slide, what I want everybody to do on their own is to answer the 3 questions that we have here and start thinking about what the graph is going to look like. Start thinking about your sketch of the graph. We're not going to do the official graph yet, but answer these 3 questions on your own and then start thinking about what the graph is kind of going to look like. And you can do a little sketch in your notebook, and then you'll see once we go over it if you were right. So I'm going to give everybody 2 minutes to work on that on their own. 2 minutes. All right, there's about 10 seconds remaining, but you can send me your answers in the chat. Whatever you have, go ahead and send it over.
Wait, what do we answer? We answer everything?
All those 3 questions right there. So what are the translations? Where is the vertex? And what's the shape of the graph? Just the same way that we've been doing it in the last few examples.
Answer it live or answer it in the chat?
Send it over in the chat first, and then we'll talk about it together. Good. I'm seeing some good answers out here, guys. I'll give you guys about like 10 more seconds to send it over in the chat, and then we'll go through it together. All right. So, A. Shout it out. What's A? Everyone's still typing.
The left.
What is A? What's the value of A?
2.
It's 2. Good. What's the value of H?
-3.
-3. K?
-1.
-1. Good. Okay. Now I'm going to start calling on you. Let me see. Who said it nicely? Okay. Jeffrey, say it in the chat or out loud, whatever you want. What's the translations? Where am I going? How many units? What direction is it going in? Say it publicly in the chat. He's typing it privately. Say exactly what you just said.
Three units left and 1 unit down.
You got it. Perfect. 3 units left, 1 unit down. So a couple of you guys forgot to flip the sign of H. So definitely just make sure we're remembering to flip the sign on the H. David, where's the vertex?
-3 and -1.
Good. -3, comma, -1. And who said this one? I think I thought I had someone say, what's the shape of the graph going to be?
I did.
Oh, there you. Jeffrey's telling me to say Bianca. Bianca, what's the shape of the graph going to be?
Did I spell stretch right? I don't know if I did, but
You forgot a T in there.
Stretch upward.
Stretch upward. Good, you got it. It's a stretch and it's opening upward. So we're going to we're going to have a skinny graph facing upward, -3, comma, -1. Just like that. So almost everyone got like 100% right on all of these parts of it. Do I have any remaining questions on how to identify all of those different transformations? Not too bad, right? Once you get the hang of it, it gets easier and easier. Okay. Finally, let's get this table going here. So -3, comma, -1. What's the number to the left of -3?
-2.
That's to the right of -3.
Oh,
-4.
-4. Yeah.
I did this backwards.
Sometimes I do that too. When you're in the negatives, it gets a little confusing. All right. And we're going to plug in -4. Let's do this together. Plugging in -4. All right, parentheses first. -4 plus 3.
-1.
-1. -1 squared.
+1.
+1. So 2 times 1.
2,
is 2, and then 2 minus 1,
1.
1.
Why are we getting negative ones?
Yeah, that happens a lot. We get 1. So be very careful when you're plugging things in. When I say, like, this part is where a lot of people make mistakes because there's a lot of negatives, positives, and you have to be careful when you're adding and subtracting. So does anyone have any questions on how I got positive 1? Okay. And now here we go. Negative 4 comma 1, negative 2 comma 1. There's my parabola. Okay, questions on this one? We have one more. Actually, it's kind of getting close to the end of class, so I don't know if we'll have the whole time to do the last one. So how do we feel? Questions on this one? Okay, so what we're gonna do, instead of doing the actually graphing it, I wanna show you guys what this might look like on a test. So here's a pretty, not simple, but this is basically what it would look like on a test. And I just wanna see how we do on this. So go ahead and read it carefully to yourself. We have 5 minutes left, so take 2 minutes and answer it in the poll, and then we'll go through it together. All right, 30 more seconds. Oops, sorry. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so see, it's easy at first, but it looks a little bit harder when it's in a test format. However, we can do this problem following almost the same exact steps. Let me show you guys the results. So clearly there's a little bit of confusion, especially between letter A and letter D. But let's take a look. So what do we know about this graph? What do we know about this graph?
We know that it's reflected because it's an open downward.
It opens downward, good. What else?
We know that it is a vertical
The
translation.
vertex.
Yeah, we can look at the vertex to figure out where, the translation. So where is the vertex?
Negative 2,
Negative 2,
comma
negative
1.
1.
Negative 2, comma negative 1. Comma 1, positive 1. So if that's the vertex, what is the value of h?
The value of h is -2.
-2.
Oh, wait, I did get it right. I'm sorry.
Yeah, no, you're good. And k is +1. And we just have to remember that -2 has to flip to become +2 when it's in the equation. Okay, so it opens downwards, so there's going to be a negative on the outside, right? A is going to be negative. Whatever it is, it's negative. So it's not A and it's not B. And then we're looking for +2 on the inside of the equations and +1 on the outside, the parentheses, I mean. So it is answer choice D. Because right here, remember, this flips. So H is -2, K is +1, and A was -1. So if you chose answer choice A, there were two things wrong with A, right? Because the answer choice A didn't have the negative out in the front, and the value of H was the opposite of what it should be. So kind of interesting, right? How when you're looking at a test question, it's not like, can you graph this? It's more like, can you match the correct graph to the correct equation? So it's important to know how to graph them, obviously, like we did today, but it's almost more important to be able to match it, right? Because on a test, you're not really going to be graphing it yourself. You're just going to be matching it to the correct answer. So any questions on this problem? If you made a mistake, the most important thing is just to know what you did wrong. It's totally okay to make mistakes in class as long as you learn from them. So does anyone have any questions on this one at this time?
No.
No. Okay. All right, y'all. So very good job today. There was a lot of participation. I want to shout out Jeffrey because you don't always participate, you know that, but today you were on point. As well as Guillermo, you've been on point today as well. So I just want to shout both of you guys out. And as usual, I have my usual people who participate. You guys know who you are. I always am thankful for you guys, but I'm glad to start seeing more and more people participating who don't usually participate. So keep that up, guys. All right, that's all. No extra homework, just the same assignment that's been up since Monday. It's still up and it's due on Friday. Nothing extra, nothing new. So I'll see you guys tomorrow. Have a nice afternoon.
Have a nice afternoon, Miss Lopez. See you tomorrow.
See you tomorrow. Bye, everybody.